Okay, sorry about that, okay? The audio's not recording, so I'm recording again, okay? Number 22, okay? Just memorize, okay? If the graph is continuous so that x equals a, this is definitions to be continuous at x equals a. Limit value is equal to actual value. Right? Even though the graph is continuous at x equals a, it doesn't mean they're always differentiable. This is a counter example there, okay? This is continuous, we know that. There is just the limit value over here, right?
Yeah.
But actual value, limit value equal continuous, but at this point, there is not differentiable, right? Totally different, okay? So remember this diagram, okay? If the graph is differentiable, or the function anything is differentiable at x equals a, that means we're already continuous at x equals a. Okay? In the reverse way, if the graph is continuous at x equals a, it doesn't mean already differentiable at x equals a. Okay? Yeah, that is by equivalent. Okay? So, 1 and 3 is the answer. Okay? Choice D is the answer. Remember, okay, this is wrong. Okay, not always working. It's okay?
Yeah.
All right, now let's do number 23. A particle moves along the x-axis and its acceleration at time t is given by this. This is acceleration 1 over t squared. When t is 1, the position of the particle is 5. Position means what that means this one. When x equals t is 1 there, the position is 5. And this is velocity. Okay? Velocity also when t is 1, velocity is 2. Right? That is initial conditions. Find the position of particle at time t equals e. They're asking you find this one. Okay? Positions at time t equals e. It is okay, right? Okay, how can you find this one? Because E is given, okay, 1 is given, right? And time t equals 1, the particle is at 5. Okay, how can you find E equals 1 there? That is what? Fundamental theorem of calculus. Okay, this is x to 1, that is what? Initial position over here. But we're going to add what in there? From 1 to E, the change over there, what? Velocity. Okay? Velocity is over here. Bt dt, isn't it?
Yeah.
But still we need what? Vt, right? Velocity. What about at is 1 over t squared is given. So from here we can find, okay, Vt, right? This is already what? The initial condition over here. Maybe you can try this one. Vt so integral of what? At, right? That is 1 over t squared is negative 1 over 2 to the negative 2 dt. Are you okay with this?
Yeah.
Okay. So what is the antiderivative of xt to the negative 2? Plus 1 and divided by negative 1, right? Plus 1 is negative 1, divided by negative 1 is, what is that? Negative 1 over t, right? That is the antiderivative. Are you okay with this?
Yeah.
And with plus c over there. Now, the initial conditions given. Take a look B over here. When time t is 1, the velocity is 2. So velocity is 2. When time t is 1, 1 over 1 plus c. Priori, you can see the a c equals what? 3, right?
Yeah.
2 plus 1 equals c. C equals 3. So velocity now is given by this way. negative 1 over t, and plus 3. That is the velocity. Okay, now put this number velocity in the integral, okay? This is now x to the 1. The initial position is at 5 there. 5 plus 1 to the e, negative 1 over t, and plus 3 and dt. Okay? So what is the antiderivative 1 over t? 1 over t is what? ln t. Are you okay with this?
Yeah.
All right? Plus, I'm going to this one. Negative ln t, absolute value, that is 1 over t. And the plus 3t, okay? We take this one from 1 to e. Now let's find this one. 5 plus negative ln e, right? ln e is a positive, we don't need the absolute value, okay? ln e is 1, isn't it? ln e is 1. And plus 3 times e is what? 3e. And the minus, you got to be careful, we have a negative number, okay? Put this number 1 there, ln 1 is 0, and still plus 3 over here, okay?
Yeah.
So finally this is a 5 plus negative 1 plus 3e and minus 3, right?
Yeah.
Which is equals to this is negative 4. 5 minus 4 is 1, 1 plus 3e, okay? At time t is in, the particle is at these positions, okay? 1 plus 3e. So 3 plus 1 is the answer, okay? Any questions on number 23?
No.
Is that understandable?
Yes.
It's okay, right? Okay. Now the next one, the area, all right? So number 24, let R be the region enclosed by the graphs of x squared minus 9y squared equals to 9. That is a hyperbola, okay? Hyperbola. And the line is x is 9. What is the volume of the solid by revolving R about the x-axis, okay?
Yeah.
So this is the graph of when you divide by 9, you understand, okay? Number divided by 9, divided by 9, divided by 9. You got this one. X squared over 9 is 3 squares, and minus y squared over 1 and equals 1. That is a hyperbola, okay?
Okay.
The graph looks like this one. This is 3. This is negative 3. Okay, the asymptote is what? 1 over 3. Looks like this one. That is asymptote, 1 over 3. The graph looks like this.
Okay.
Okay, that's the hyperbola, okay? And the region enclosed by x is 9. X is 9 over here. This is x is 9. So this is enclosed one. We don't care about the left hand side, okay? Right. So we revolve this one about x-axis. So it's the same thing, okay? So x-axis looks like this one. This one turn around over here. It's actually the same over here, but this one is now a circle. Are you okay with this?
Yeah.
So this is a disk, right? We said this is disk. There is no empty inside. So this is the, for example, this one in the middle, the random, some x over here. This is what the radius r, right?
Yeah.
R equals to y, which is what? 1/3 of x. No, it's not, okay? Yeah, this is y. You have to find over here, okay? Anyway, this is asymptote. This is R anyway. I'm going to take this is R. So volume of this one. Volume of this one. Okay. We take integral from 3 to the 9. Okay. 3 to the 9. What is the area of this one? Over here in January in the circle. Pi R squared. And dx. Are you okay with this? So R is the value of y over here, okay? Now we're gonna find the y, okay? Now take a look. What is the R? This is R. X squared, so you can see it over here, right? X squared minus 9, that is equals to 9y squared, okay? When you divide by 9, that is 9 over here. That is y, okay? So we need what? R is, you can make a square, right? But this is the R squared is y squared, okay? This is R squared means y squared, okay? This is R equal y. R squared is y squared. So y squared is y, x squared minus 9 over 9, okay? So this is now looks like this one. 3 to 9. I'm going to move right pi out, get the constant. That's the easiest way. R squared is what? This one. X squared over 9 and minus 9. That is dx. Okay? Yeah, that is the volume. Okay? And 9 is moved to the front. That is easier way. Okay, we can move to the out. 9 is out. Pi over 9 there. 3 to the 9. Inside is what? X squared minus 9 dx. Antiderivative over this one, pi over 9. Antiderivative x squared is what? Plus 1 divided by 3, right? So x cubed over 3 and minus 9x, okay? Take integral from 3 to 9, okay? Okay, put this number 9 in the x. 999, okay? 243, okay? Because this is 9 times the cube divided by 3 is what? Okay, 81 times the 243, okay? Pi over 9 and 243 and minus 9 is what? 81 and subtract 3 cubed is 27 and divided by 3 is 9 and also 9 times 3 is what? 27, okay? Okay, keep going down. Pi over 9. 243 is 61. How much is that? Okay. 243, 61. 281, right? 182. Are you okay with this?
Yeah.
Sorry, 81. 162, right? Okay. This is 162 minus 18 minus 18, okay? So plus 18, plus 18, how much is this one? 180, okay? So pi over 9 times 180. Okay, one more times. Pi over 9 times 180. That is 25, right? That's the volume, okay? This one is up to number 24 there. Here you go. Okay? Now remember, this R squared is y squared, okay? From here we can get the y squared directly, okay? From here y squared is x squared minus 9 over 9, okay? Put this number into there here, okay? All right. This is a very popular questions, okay? So remember.
Yeah.
All right, number 25. F of x is x squared e to the negative x. The graph of f is increasing for all x such that we can find the right interval for the graph is increasing. Increasing, we need to use what? First derivative. Okay, if first derivative is greater than 0, that is we said decreasing.
Yeah.
It's okay?
Yeah.
Okay, anyway, this is a continuous functions, okay, we know that, okay, there's no discontinuity, okay? Okay, now let's find first derivatives, f prime x, check it out, x squared e to the x, negative x squared derivative is 2x times e to the negative x. After that, first one don't touch, second one is derivative of negative e to the what? Negative x. Are you okay with this?
Yeah.
E to the negative x derivative is equals to e to the negative x, but we take integral, okay? Take a derivative one more time is negative x. That is negative 1, right? That's right, this one. Now let's find this is greater than 0. Increasing. Now you can see that there is a common, right? Okay, I'm going to write one more times. 2x e to the negative x minus x squared minus e to the what? Negative x. Okay, keep continuing this one. What it is? X times e to the x. Okay? X times e to the negative x 2 minus x. That is greater than 0, okay? We know that e to the negative x never be a 0. They're always a positive. So we can cancel out. Okay, we don't need this one, okay? They're always about greater than 0. You can divide by e to the negative x both sides. We got y, x times 2 minus x. Finally, we got this one. X times 2 minus x is greater than 0.
Yeah.
Okay? So what is this one? How can you solve this one? This you can make a graph over here. Y equals x times 2 minus x. So we have x equals 0, x equals 2 over here, x equals 0 over here. This is actually minus x squared, right? Minus x squared plus 2x. That's right. This is the graph is what? Open downward. Okay? Or you can do this one too. Minus x, x minus 2. Okay? That is minus is downward. The graph looks like this way. Okay? This is the graph of y f prime x. Okay? Y prime. Okay. So this is minus. That all the way decreasing. Here, plus is what? Increasing. After 2, that is decreasing again. So increasing only this intervals between 0 and 2. Okay? So if x equals 0 and 2, f prime x is a positive. That means f of x is increasing on this 0 and 2, okay?
Yeah.
So 0 and 2 is the answer, okay? Okay, the next number 26. We did this one last time already. Okay, we try this one more time, okay? I'm delete this one. Just a moment. This way. F is the function defined there. F of x equal to minus ln x squared. What is the equations for the line tangent to the graph? F at x equal 1. Maybe I showed what the graph of this one in case, okay? That is easier way to understand, okay? Okay.
Yeah.
And now you can see that That's most of you, okay?
Yeah.
So I'm gonna graph of this one, 2 minus ln and x squared, okay?
Yeah.
That's the graph. Very weird, right? So x
Yeah.
equals 0, x equals 0, that is a vertical line, that is asymptote. Okay, that is asymptote. X equals 0. This is x equals 0. I'm going to put up here x equals 0, that is asymptote, okay? That is all the asymptote, 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 okay? Anyway, this graph. So we're going to find the equation of the line tangent to this graph at x equals 1. Where is x equals 1 over here? X equals 1 over here. This is at x equals 1. The y is 2, right? Okay. So we're going to make the tangent line at this point. Okay. All right. So the point is 1 and 2. We already know that. Okay. So the graph looks like this way. This point, actually, when x is 1, y is 2, we gonna find the equation of this tangent line, okay?
Right.
Okay. All right. Anyway, we need to find the slope of this line at x equals 1, right? So we're gonna find this. So how can you find the f prime 1? That is the slope of this line, okay? And we got the point already. That's enough. Okay.
Yeah.
Okay, to find the actually we don't need the graph, right? Just take a derivative at x equals 1 there. Okay.
Right.
Constant derivative is 0, negative x squared over 2x. Are you okay with this?
Yeah.
Right? So that is equals to, you know that, right? ln u derivative is what? U prime of u, right? You know this one. This u prime is 2x, u is just still x squared. When you divide it by x, this is 2 over x. That is the derivative functions. At x equals 1, what is it? At x equals 1, that is negative 2 over 1 equals negative 2. Slope of this one equals negative 2 there.
Yeah.
We still need a point. We just got this point from the graph, but still we don't know this one, okay? If we don't know this one. So using original functions, we can find the value of y there, okay? What is this one? F of 1. Put this number 1 in the equation. 2 minus ln 1 squared is 1. This is 0, so that is 2. That's why this is 2, right? Now you can use what's point to slope form or slope intercept form directly. I'm going to use a point to slope form. Y minus y1, y equals 2, slope equals x times x1. From here you can transform the equation into the what? Slope intercept form. They are all slope intercept form, right?
Yeah.
So y equals negative 2x and plus 2 and another plus 2 there. So y equals negative 2x plus 4 is the answer, okay? So that's the equation of this line. Y equals negative 2x and plus 4, okay? Okay, this is a slope field. Okay, slope field is some graph. Okay, some general solutions. Okay, we just check that slope at this grid line. Okay.
Yeah.
Okay. So also you can create a slope graph, slope field graph using your calculator, okay? But you can do that is working only what TI-89,
Yeah.
okay? Because I cannot probe your TI-89 over here, okay? This is Windows 11 version. I cannot, okay, probe my calculator. Windows 10 is okay. So this is Windows 11, right? Anyway, which of the following could be differential equation for the slope field? Okay, check it out over here. First, check out this special case. Slope is all zero, right? Slope is all zero. This is what? Undefined, okay?
Yeah.
There's no slope. That means what? Undefined. At this point, undefined, and x equals -1, okay? From here, we can check out the first one over here, okay? At x equals -1, slope of elbow, right? Slope is 0. That's the first one.
Okay.
Which one has at x equals -1, that is 0, okay? For any variable y, okay? For any variable y, they're all 0 over here, okay? All right. Put this number. This one is x equals -1, that is 0. Put this number. This is slope, right? Derivative is slope, isn't it? This line is what? Slope, okay? This line is what? 0. So when you put over here x equals -1, this one is dy dx slope is actually equals to what is that? -y minus y, -2y. Alright?
Yeah.
So -2y, y equals 1 over here, it's gonna be -2, right? Y equals 2 is what? -4. It has a slope. That is not 0. That's wrong, okay?
And
From here, they're all the way 0, okay? So when x equals -1 there, dy dx, put this number -1 there, 0 over y minus 1. That is 0. Are you okay with this?
yeah.
That's fine, right? This is both out. Still is okay. Third one is what? Dy dx is what? X equals -1, -y plus y. Oh, still this is also 0. That's fine.
Yeah.
The d is what? Dy dx -1 plus 1, right? -1 plus 1 is 0 over y. Still 0 is fine. This is also, they're all working. -1 plus 1 is 0 over, okay, x equals, x equals, I'm sorry, x equals -1, right? 0 over -1 is still 0. The next one, when y equals 0, over here, right? They are all y equals 0 over here, isn't it? Okay? At first, this is y equals 0. That is undefined. So you can check it out. Denominator 0, right? Y equals 0, second one. Check it out, second check. This is y equals 0. X plus 1 over y equals 0. 0 minus 1. That is not undefined. Okay?
Yeah.
But that is undefined. This is not undefined, right? So this is out. Undefined means what? Denominator should be 0, okay?
Yeah.
Over here, 0. Okay? 0 is what? The line of the 0, okay? There is no line means what? Undefined. What about the number 3? What about y equals, so dx dy is what? X plus 1 over 0, right? That is undefined, isn't it?
Yeah.
But this is fine. This is not good. But there's no 0 here, okay? There's no undefined one. So this is wrong. Okay? So only choice D at y equals 0, that is undefined. Okay? Are you okay with this?
Yeah.
Yeah, that is we set the slope field Okay, in the class we didn't do that, right? This one, because this is a very simple questions. Okay, just check it out. Okay, slope is 0 or undefined. Okay, at y equals 0, slope is undefined. Okay,
Yeah.
that's number 27. Okay,
Yeah.
and number 28. You have a table there. F is original function, it's a derivative, and the g and g of derivative. Okay, so there are four selected value of x. Okay, and show that they are all value. Okay, so f and g, the function that are differentiable. Okay, so f and g, they are differentiable, they are continuous. Okay, have value shown in the table there. If ax, you create new functions. This is f times g over 3x. Then a prime negative 2 is how much? The derivative, right? At x
Yeah.
equals negative 2. So we take a derivative over here.
Okay.
A prime x. I'm gonna make it big. I'm gonna write down over here. Prime x. Take a derivative. Derivative of this one, f prime, okay? F prime g of x, right? So f prime g 3x. That's it. But inside one, that is not x. That is a function of x, right? So g first, okay? G prime, we take right g prime there, okay? Times g prime 3x. That is chain rule, right? After that, going into the 3x, that is not x, that is still function of x, which is a 3x. Take a derivative of 3x is a times 3. That's it. Okay? Now you're gonna find what? At x equals to negative 2, okay? Put this number x equals to negative 2. F prime negative 2 is that equals to what is that? F prime g 3x negative 2 is a negative 6. And the g prime negative 2 is about negative 6. And times 3. Are you okay with this?
Oh, yeah.
Now let's find the g prime negative 6 first. First we can try. G prime negative 6. Here, right? This original g over negative 6 here is gonna be equals 2, right? This value is 2.
Yeah.
So this one equals how much? F prime 2 there, okay? G negative 6 is 2. The next one, g prime negative 6. G prime negative 6 is a 9, right? So this value is 9.
Yeah.
And times 3. So that is equals to 27 and f prime 2. F prime 2 is how much? Here. F prime 2 is 6. So this one gonna be 6 times, 9 times, and 3. 6 to 9 is what? 54. And times 3, how much? 162, right?
Yeah.
Are you okay with this? Yeah. The derivative, okay, of a at x equals negative 2 is what? Is actually 162, a very steep, right, slope, right? Okay. Anyway, that is 162. Okay, the next one, section 1, part 2 over here. From here, we can use your calculator, okay? You have two semicircles there. They set semicircle, right? Yeah, two semicircles and two line segments.
Yeah.
So which of the following is not true? Okay, yeah, from here we're gonna find out which one is not true. This is a graph of f, function of f, right? Not derivative, okay? This is the original graph. This is the original graph. Y equals f of x, not f prime. So first we can try f prime derivative at x equals 3.5 is 0. The slope of the line tangent to this curve is 0. Is correct? Where is
Yeah.
negative 3.5? In the middle, negative 1 and negative 6. Right? Negative 1 plus negative 6 and divided by 2. This is actually in the middle, negative 3.5, right? On
Yeah.
semicircles. Okay? So at this point, slope of this line of tangent in the middle of here, right? That is f prime at x equal 3.5 slope is 0. That's true, right?
Yeah.
Yeah, slope of tangent, right? Second one is slope of tangent at x equals negative 1. It exists over here. Derivative at x equals 1. How to think? It's going to be vertical line tangent, isn't it? Because this looks like this way. The whole circle at this point, the tangent line is about vertical line. Are you okay with this?
Yeah.
This radius and the horizontal and the vertical line, they are already perpendicular, right? So this line of tangent is a vertical line. Vertical line. But this vertical line tangent, the derivative does not exist. D and E, okay? Because that is a vertical line. This is wrong. That is not true. We continue to check out right C, D, E, okay? F prime 4 does not exist. That's right, at this point. Sub-corner, right? From
Yeah.
here, that is a line of tangent is negative. The other side is about this line. We have two different slopes. Anyway, that is not exist, okay? That doesn't exist, okay? Yeah, vertical line, anyway, two different tangent line over here, okay? One is vertical, the other one is the same as this line. So that is not exist. That is true. F has a point of inflection at x equals negative 1. At x equals negative 1, that is a point of inflection, this point. Yes, this is concave down.
Yeah.
Yeah, that is concave down, right? This is concave up. This point is definitely right. Point of inflection, right? That is true. F has a relative maximum at x equals 7. Yes. This is continuous. But anyway, not differentiable, but still, this is what? Highest point for its neighborhood over here. Okay? This is f of 7 is undefined. It doesn't matter, right? Okay, what is the critical point? F of 7, f prime, okay, move it down. Is 0 or undefined, okay? That we set critical point, right? Yeah, this is critical point, but this critical point is okay too. It has local maximum, right?
Yeah.
That is the highest point. That is true too. So choice B is the answer, okay? So number 77. The function f is defined f of x equals something like that. For what value of x the graph of f change its concavity, right? Concavity.
Yeah.
So this point is what is the point of inflections or inflection point. You're gonna check it out. Or you're gonna find the inflection point, okay? How can you find the inflection point? Second derivative
From the original.
or first derivative is okay too. Find the first derivative first. F prime x. 3x squared minus 6x plus 5. 5 is constant 0. ln x prime is what? 1 over x.
Yeah.
Second prime. First prime. If the first, okay, slope of first prime is 0, okay, derivative of first prime is 0, there is inflection point, okay? Or you can use what second derivative is okay too. I'm going to show you the graph of both, okay? This is 6x and minus 6, and 1 over x derivative is how much? Minus 1 over x squared, isn't it?
Yeah.
Okay? At x equal 1, there is what? Asymptote. Okay? So, we're going to make a graph over here, okay? Because this is number 77, we can use our calculator.
Then we can find the inflections from the after you make the original.
No, over here, because to find the inflection point, we need a first derivative or second derivative only, okay?
Yeah.
If you have a good eye, you can use first derivative, the original, okay? It's okay. I'm going to show you every questions over here, okay? First one, I'm going to use, okay, first derivative. How we use, first derivative to find the inflection point, okay? So what's still y equals 3x squared minus 6x and plus 1 over x. Oops, I'm sorry. 6x plus 1 over x. That's the graph. Can you see that? At x equals 0, there is asymptote over here, right? There is x equals 0, there is asymptote. We have two different graphs. The left one, the other one over here. Are you okay with this?
Yeah.
Okay. Where is the inflection point? Inflection point is what? Second derivative is what? 0, right? Okay? Okay. So derivative of the first one, derivative of first derivative, right? Okay. So that's the second derivative, okay? You understand?
Yeah.
The derivative, okay, our slope of f of x, f of prime x, that is second derivative, okay? But to be 0 over here, the tangent line is 0, okay? Where is tangent line is 0? Here, right? The lowest point. This is the lowest point, I think. 1.13. Okay? So here is you can make the line is what? The line of tangent slope is what? 0. Are you okay with this?
Yeah.
Alright? This is derivative. Okay? At this point it has what? Inflection point. Okay?
Yeah.
Alright. Another one is over here. Second derivative. We're going to try use the second derivative over here. 6x minus 6. You can use a second derivative too. I'm going to use over here second derivative. Y equals 6x minus 6 and the minus 1 over x squared. The line, this color, right? Black color is what? Second derivative. Okay? This point over here, right? This second derivative is lower down is what? Negative. That is what? From this point all the way down over here, negative means concave down. After this point is a part is a concave up. So this point is what is that?
Inflection
Point
point.
of inflection point. Same as this, okay? From here, this number in the middle of here, 1.13, 1.1, the same number, right? Okay? Because this one, black one is a second derivative. Okay, green one is a first derivative. Anyway, at this point, the same number, right? 1.13, there is inflection point. Okay? So we can use right first derivative, but this one and a second derivative. Second derivative is what? Plus, minus, you can change over here, okay? That is a negative concave down from here to the right all the way up. That is concave up, okay? So at this point, they change what? At this point, they change concavity, right? So at this point, okay? At this point, 1 equal 1, 3, okay? But not 0, okay? This in original, we don't know y value. Anyway, x equals 1.13, there will be inflection point. I'm going to put up here original point, okay? Original is this one. Y equals x cubed minus 3x squared and plus 5. And one more plus ln x. Okay, that's the graph. Okay, this is the graph over here, all the way down. Take it out. At this point, it was before 1.13, that's the inflection point. At this point, second derivative, right? Still 1.13, 1.13, right? So where is this original? This is concave up over here. At some over here, there's concave down over here, right? So where is this point? This point, right? This point. Take a look at this point. At this point, 1.13, they changed their concavity, right?
Yeah.
Okay, to the right to the right of this point, there's a concave up. To the right, to the left of this point is a concave down over here, right? Can you see that concave down over here, right? They're all concave down from here to here. Are you okay with this?
Yeah.
But over here, this is 1.13. To the right is a concave up, right? So they're asking you to find the inflection point, the value of x. So that equals to what? 1.13, right? This point, 1.13, or you can use this point. Okay? So if you have a good eye on original, also you can find it. But it's very hard to find this inflection point from the original graph. Okay? That's why we use second first derivative, this one, or second derivative, okay, to find the inflection point. It is understandable?
Yeah.
Okay. All right. So the answer is B, right? At x equals 1.13, there is inflection point. Okay? All the way down, okay? 1.13 over here, 1.13 over here, 1.13 over here, okay? 1.13, okay? That is the inflection point. This is in the original, right? Inflection point is when x equals 1.13, y equals 2.734, okay?
Right.
All right. Now we're gonna move on to the next questions there. Number 78, we have a graph. Okay, so from 0 to 4, there is a constant, right? Slope is 0, constant functions. After this, slope is negative. After 6, going down exponentially, finally, at x equals 10, that is 0. We have 3 piecewise functions. And the area under this curve from 6 to 10, this area is 1 point. This area is actually equals to this area. Okay, I'm going to write it down. Different color, that is better. this area between 6 to 10 is 1.8. That's the area. And the g prime x equals to f of x, okay? G prime x equals f of x. This is a graph also what? Some derivative function of some function over g of x, okay? And then we're going to find this one, g over 10 minus g over 4. Okay, how can you find this one? This is also a fundamental theorem of calculus, okay? Do you remember this one? G over 10, you can say. G over 10, you're going to find the rate from g over 4 here, okay? G over 4. From here, you can add the all change of g prime from 4 to 10, g prime x and dx, isn't it? That is our definitions, right?
Yeah.
So we're going to find what change between x equals 4 and 10. So this is exactly the same with this one, g over 10 minus g over 4, that is exactly equal to this one. There are 4 to 10 g prime x. G prime x is f of x. I'm going to replace with f of x and dx. That's it. They're asking you to find the value of this one. Change all variable like g prime x between 4 and 10. Okay. Where is 4 and 10? From here.
Yeah.
We're going to find, okay, between 4 and 10 is what you're going to find. This is area is a change of f of x between 4 and 10.
Yeah.
This already we got 1.8. Now let's find only this one, okay?
Yeah.
This is 4. This is 1. That is trapezoid. Upper base is 1, bottom base is 4. This is the height. 6 minus 4 is what? 2 is the height. So area of this trapezoid equals to 4 plus 1 and times the height is 2 and divided by 2. So 2 is cancelled out. The area of this trapezoid is 5. This area is 5.
It is.
Another 1.8 there. The total area of this one is 5 plus 1.8 is 6.8, right?
Yeah.
Okay. The difference between g over 10 minus g over 4 is actually equals to 6.8. Okay, choice C is the answer. Are you okay with this?
Yeah.
All right. Number 79. F is the functions given by here, e to the square root x. If the slope of line tangent to the graph f at x equal a f of a, that is a point, right? Actually, when x is a, y is y, e to the y, square root a, right?
Yeah.
Yep, slope of a line tangent is 5. That means, what is that? F of prime, when a equals to, a, we don't know. Okay, anyway, some value of a, that is equals to 5, all right? That's meaning. Are you okay with this? Slope of tangent is 5 at x equals y, a over here, okay? So f prime a is 5, okay? What is the value of a? Okay, take a derivative, right?
Yeah.
Okay, now let's find the value of a first, okay? So f prime x is how much? From here, you can find f prime x. This is the exponential function e to the what? Square root x. But this is not x. This is a function of x. We take multiply derivative of square root x, right? Square root x is what derivative? Square root x that is equals to x to the 1/2, right? Okay, take a derivative. You know this one, right? 1 over 2 x to the negative 1/2. Are you okay with this?
Yeah.
This is 1 over 2 square root x. That is derivative. So you multiply this one 1 over 2 square root x. That is derivative. Okay.
Yes.
So at x equals, for what value of a, the derivative is 5. So you can find this one. This derivative is 5 for what value of a? Okay, put this number a there. E to the square root a, 1 over 2 rat a, that is equals to 5 there, okay?
Yes.
So how can you find this one?
Take.
You have a square root a there.
Because
This is a square root a
saying-
down over here.
Because it gives you a slope of the tangent, you can take derivative of slope, so.
Okay, we need to use our calculator, okay?
Okay.
Now let's make a graph of this one, e to the a. A is now variable, right? Still, we don't know the value of a. That's why it looks like a variable. You can use this one. It's scale. You can use x. It's okay. A over times 1 over 2 square root of x. Some value of x, we have a 5. That is what?
Yeah.
We're going to find intersection, right, of this one. So now let's find this one, okay? You can see the graph over here, right?
Yeah.
Okay. So I'm going to prove here. I'm going to take them out all of this one. First one, I'm going to make this is, you can use your calculator, okay? This is y1 equals this is y1, this is y2, okay? y2 is 5, y1 is this one, and find intersection, okay? So y1 equals, that is y1, e to the square root x, okay? E square root x.
Yeah.
Okay, where is it? Oops. E to the what? Square root. Where's square root? Okay, square root x. That's wrong, right? E to the what? Up there, square root x. Okay, that's it. And times 1 over e2 square root x. 1 over 2 square root x.
Yeah.
Okay? We have a graph there? Oh, no graph. What is this one? This is no graph. Out. Okay. Now we have a graph. Okay, I'm going to take them out. Okay, this is right. E to the square root x over 2 square root x. That's the graph over here, okay? The other graph is y equals to 5, isn't it?
Yeah.
So you're going to find the intersection over here, okay? Can you see the intersection? Okay? Right? So we're going to find what two value over there. We are the intersection over here. When x equals 0, y is 5. Okay? So there's no x equals 0, right? Because what? If this is x equals 0 there, that is undefined, right? Derivative is not exist, okay? Are you okay with this?
Yeah.
So at x equals 0, that is what derivative is, can you see it over here? Line of tangent slope is 5, okay? This one is slope is what? Vertical line. At this point, the slope is vertical, which is what? X equals 0. Okay?
Yeah.
Okay? But we have a slope of 5, right? So we're going to go the other side over here. All the way down. This point. Okay? Can you see it over here?
Yeah.
12.76, 12.796. Okay, this is the value of A, okay? At this point of A, it has about 5 over here. Can you see that over here?
Yeah.
All right. So we're going to find out, okay, x equals, slope is 5 at this point, x is about 12.796, okay? So we are at 12.796 over choice E there, okay?
Yeah.
Choice E, and as slope is what? 5, okay? So I'm going to, show the original graph anyway. Y equals, this is the original graph, y equals e to the what? Square root x. This is square root x. Okay? At this point over here, this point, right? From here all the way over here. 12.76. Let me see. 12.76. 796, a little more. This one, okay, 12.79, a little more at this point, okay, this point, when you make a right tangent of a line, it's going to have a right slope is what, 5. Are you okay with this?
Yes.
Okay, this one has, when you make the line of your slope is 5, okay? So this one looks like this graph. This one over here all the way down, okay? This point 12.796. When you make a tangent line, slope of this line is 5, okay?
Yeah.
So at this point, okay, that is the value of A. Okay, number 80. Find the point on the graph f of x equals x squared plus 1 that is nearest to the point 3, 0. Okay. What is the y equals x squared plus 1? This is the graph of y equals x plus 1.
Yeah. Oh.
One over here. This is the graph, right? We have a 3 and 0. Okay, there is the point from here, maybe somewhere up here. That is the nearest point. This is a little bit longer. We don't know where is it. Okay? So anyway, we don't know, right? So we're gonna find this point over here to nearest a short length. Okay? All right. Now let's find this one. If this point is x and y, this point is y, x and y. Okay, what is distance over here? Can you find the distance? Distance square. Okay, maybe you can use the distance. Okay, distance is what? x minus x1, right? X minus 3 squared and plus y minus 0 squared, y squared. Is it okay?
Yeah.
I'm gonna take right optimize d, which is what the minimum, right, value. Okay, that is what nearest point, isn't it? So you can use. Now we need to find minimum, right? That is what minimize. Okay.
Yeah.
To minimize, we're gonna find the d x. Are you okay with this?
Yeah.
Okay. That is what minimum. Okay. To find what zero equal anyway. At this point, it's gonna have a minimum, right, or maximum. But this time's only minimum available. Okay, we know that. Maximum is what undefined. Okay, it can be maximum allowed there. It's just only minimum. At this point is what dx is must be equal to zero, right? Derivative is zero. Okay. Now let's find. This is d in terms of x over here, y squared. Okay, this is the y equals to x squared plus 1. Put this number y squared in there. Okay, y squared is what is there? In terms of d, we got this one, x minus 3 squared and the plus y squared equals how much? X squared plus 1, another square, right?
Yeah.
Now take a derivative of this one, okay? Now inside, maybe you can simplify this one. Inside, x minus 3 squared is what is there? X squared minus 6x plus 9. Second one is x to the 4 minus 2 plus 2x to the square and plus 1. A little more simplified over here. This is the highest degree, x to the 4. Second one is x squared is what? X squared, 2x squared there, 3x squared, and the minus 6x and the plus 10. Using this one, take a derivative, right? Okay. Or you can use d squared, it doesn't matter. This is d squared is what? We don't need the absolute value. Okay? So anyway, dt must be equal to 0, right? Because this is what? 2, when you take a derivative, 2d d prime. Are you okay with this?
Yeah.
It's same thing, okay? To the d prime. Okay, if you're not comfortable for this one, okay, we can, doesn't matter, d square, okay? Okay, square root 1/2, right?
Yeah.
Okay, d prime, not take d prime, 1 over 2. So minus 1 is what is there? x4 plus 3x squared minus 6x plus 10 minus 1/2 must be going down to the denominator, okay? And we take right derivative of this one times what is there? 4x cubed derivative 6x minus 6, okay? This is going down there to square root x to the 4 plus 3x squared minus 6x plus 10 and over numerator, right? 4x cubed plus 6x and minus 8. This one must be equal to 0. You have to solve this one. This one cannot be 0, that's undefined. Okay, so we're gonna find the value of x, okay, when this value is 0. Are you okay with this? Okay, now let's find, okay, the make we're gonna use my calculator again, okay, to make a 0 be, okay? Now make a graph of this one. For what value of x it is 0, okay? Take them out. So y equals 4x squared, 4x cubed, right? Not squared. X cubed plus 6x plus 6x and minus 6 For what variable that is 0? That's the point over here, right? On this point, you can see that, right? Derivative is what is there? Decreasing, increasing. This is about minimum, right? Okay, well, how much this one? 0 point, okay, at x equal y equal 0, 0.735, okay? The value of x equals 0.735. From here we can say x equals 0.375. Are you okay with this?
Yeah.
Yeah, right? Okay. This is the value of x. At this value of x, okay, we can see that at this value of x, this is negative. The graph is looks like this one. This is f prime, okay, d prime. Minus is what? This is plus, okay, decreasing, increasing, looks like at this point the graph it looks like this, okay?
Yeah.
It has minimum, but we need to find the what? Y coordinate too, okay?
Yeah,
From here you can find over here, y coordinate, what is that? Negative 0.5 n squared and plus 1. Okay? So now let's find this one.
That equals
0.735 n squared and plus 1, right? 1.540, okay? That's the answer. Okay? So this point around over here. Okay? So now let's find out the point on this curve, okay? I'm gonna show you the graph. Y equals y equals x squared and plus 1. Okay? What is this point?
uh
0.375, okay? 3 and 0 over here. Okay, 3 and 0 over here. The nearest point, right? To nearest distance, the point is, how can I have this one?
Yeah.
I'm gonna find 0.375 and 1.540. Here, right?
Yeah.
At this point, another one is what? 3 and 0. 3 and 0, right? That is the distance. When you make the line over here, okay? This line over here, that is the nearest, that is what? Minimum valuable line, okay? So, okay, minimum line from this to point. Are you okay with this?
Yeah.
Okay, all right. This is the optimization, okay? So we're gonna optimize this there. This is we said primary equations. Okay, this one is the primary equations. This one, I'm sorry, this one. So we're gonna optimize this length, okay? Right, number 81, we have a function of f over here. So for intervals, f is increasing. To increasing or decreasing, we need to use what? First derivative always, okay? First derivative is positive, that is increasing. That is increasing. Okay? Now take the first derivative. That's your quotient rule, right? x squared minus 9n squared.
Yeah.
Okay, first derivative is just first one numerator derivative is how much? 8x and times denominator.
Yeah.
And don't touch the first one. 4x squared minus 16. Take a derivative of denominator 2x. Okay? Because we have to use our calculator, you don't have to simplify this one, okay? You can use this one, the graph of this one. So we're gonna find what? Increasing, right? Which is positive on this graph, okay? Actually, we don't need to simplify, okay? Okay, now let's make a graph of this one, derivative functions. Y equals 8x x squared minus 9 and the minus 2x first, okay? 2x times 4x squared and minus 16 close, right? And we can divide it by all, everything is divided by what is the x squared minus 9, okay? Parenthesis x squared minus 9 and close and squared. That's the graph. We're gonna find the increasing, right? So which section that is all positive over here, okay? Increasing. Take a look over here. Can you see that over here?
Yeah.
X equals 9 over here. X squared is 9. X is a plus minus 3, right? Plus minus 3, there is what? Asymptote, okay? The denominator 0, okay? I'm going to x equals 3 asymptote. Another one is x equals negative 3 asymptote. So from here, negative 1, right? They're all the way down over here, okay? They never touch this one. This is always a positive here, right? This section is a positive. They're all positive over here, right?
Yeah.
They're all positive. They never touch. Okay? So from negative 2 up to negative 3, they are all what? Positive, right?
Positive. Yeah.
So on this section, the graph is what? Increasing.
Yeah.
Up to here, increasing too, right?
What did you say?
Yeah. From negative 3 to the what? Up to 0, still increasing, okay?
Yeah.
Over here, right, the graph is what? Down over here, negative. They are all negative. They are all decreasing, okay? So first one is what? Negative, infinity to positive, negative to not including this one, okay? This is all the way down, right? All the way increasing. And from negative 3 up to 0 also increasing. Are you okay with this?
Yeah.
Okay, choice D is the answer, okay? Because at x equals negative 3, there are vertical asymptote, okay? So choice D is the answer, okay? All right, number 82. This is the graph of f prime. There are derivative functions, okay? The initial value at x, this is y equals f prime x graph, okay? By initial, okay? At x equals 5, y equals 0. So the original function over here, I'm going to make an original function over here. This original function y equals f of x. When x equals 5, that is what 0 over here. we start from it. This is initial conditions. The value of y, okay? On the x-axis, y is 0. And the negative 5 to 0, their area is what? 12.8. That's increasing, right?
Yeah.
All right, so how
It's going.
looks like the graph over here? So x equal to 1, right, from here, sum of this one, from here, 0 to plus 128, when x equal to 0 over here, original function is what? 12.8 over here, okay?
Yeah.
This point is 12.8. But how looks like this one? This is the derivative, so there is, right, the slope of this is 0, there is inflection point. Over here, inflection point over here. That is increasing, both way increasing. But slope is what? Positive, concave up increasing, right? So it looks like concave up increasing.
Yeah. Still.
After that, still increasing, but there is a concave down increasing over here. Okay?
Okay.
This point is what? Inflection point. After that, f prime x was negative 6.8. Okay?
Yeah.
We still have a 12.8 up to 5. At this point also what? Inflection point over here, right? When x is 5, how much is that? Sum of this one. 12.8 minus 6.8 is what? 6. Are you okay with this? So when x is 5, the value of this one is 6. Are you okay with this?
Yeah.
Okay. Now what happened over here? That is minus means what? Decreasing, right? From here it's going to be decreasing. The slope of this one is negative. Okay? Concave down decreasing. Okay? Up to here, concave down decreasing. Okay?
Yeah.
Still this is decreasing over here, but and finally 5 is going to have like 6. Okay? There is a 5 over here, that is still 6 over here. It's okay, that is concave up, right?
Yeah.
Decreasing. That will look like this one. But this is not, right? At x equal 5, still what is that? 6 over here, right? 5 to 7, that is what? Negative, there is what? Area of this one, negative 2.3, okay? We still have a 6 over here.
Yeah.
6 minus 2.3, still 4.7. They never touch the 0 over here, okay? This is a decreasing, but there is a concave down, right? Decreasing, but never touch. Over here, still positive. Which one is very similar to this one? This one, right?
Yeah.
This is below the no good. This is not increasing. This is 0, no. 0, no. This one is still over here, okay? So at this point, there is inflection point over here. And going down, another, okay, inflection point there. That's right?
Yeah.
This is inflection point. Okay, this is what, 12.8. Okay? At this 5 over here, that is how much? 4.6 over here. This still 4.7. Okay? So choice E is the answer, okay?
Okay. Yeah.
Okay, I'm gonna post like this video on YouTube, okay? You can take a look at this one, figure out again, okay?
Okay.
Okay, after this class, okay, maybe after, I have another 2 more class there today.
Okay.
After 9 o'clock. Okay, right now, okay, that's another.
You send the email.
Yeah, okay, I have another 4 hour class. So after 8:31, at 9 o'clock, right? Okay. After 9, I'm gonna send out the okay to today's work and the video. Okay.
Okay, that's fine. Okay.
All right. Okay. Also next time. Okay. All
Okay.
right.
Thank you, Dr. Chung. Have a good night.
Okay. You too. Bye.
Yeah.